Hello students, so you are watching Suffixers Smart Classes. Till the last class we have done till spherical and cylindrical capacitors. I hope that concept is clear. Okay, if you have any doubts regarding that, you can put it in the comment sections. Okay, so your comment sections will will help me to improve my lectures, because that will help me whether exactly you're understanding or not, right? It is not necessary that you have to say something very good about me in the comment section, but if you see you're having some problem, you need to address that particular corner. Okay, when the audience is there, the students are there in front of me, like according to the requirement of the students, we design our classes, right? So according to the requirement, things comes out. Okay, so when the student is not there, only the camera is there. So exactly, you do not know, I cannot see you through the camera also, I do not know whether you're understanding or not. So only option is there, either you communicate to me through WhatsApp, or you put your doubts in the comment sections. According to that, I'll be adjusting my lectures in futures. Okay, so today what exactly we are going to do, that we are going to discuss about a combination of capacitors. Okay, parallel plate capacitors connected in series, connected in parallel. So this particular topic is going to be very important, very important. Okay, so that is why you'll have to see these particular lectures very carefully, and I believe after seeing these lectures you'll be left out with no doubts. Okay, or if you still have doubts, you have another options. Okay, you can put in the comment section, or you can WhatsApp me. Okay, let us start. First of all, let me talk about. Now, first of all, let me show you a capacitor of capacitance C connected across a battery. So what exactly we do? We can say I have already explained it, and I have explained it in 2-3 different ways. But in these situations, now I'll be explaining it in this way, that when a battery is connected to a capacitor, from this battery a charge of Q will go and deposit here. Okay, I'm taking capital Q, and as a result a minus Q will develop here, and a charge of Q will be coming out. Okay, we can say it like this, that this particular battery has taken out a charge Q and deposited here, or we can call it a charge Q has flown here, a plus Q will get deposited, induction will take place, minus Q will stay here, and plus Q will be repelled by this plus Q, so this will be coming out. We know this is an isolated plate. Okay, now it is connected to a battery, of course. So from this one, okay, plus Q, minus Q, and plus Q, minus Q will remain, plus Q will be flowing out. This picture is already known to us. Okay, now I'll be going for a combination of capacitors. I'll be going for combination of capacitors. Combination of capacitors. Combination of capacitors. What exactly is combination of capacitors? Okay, so for example, 2 capacitors are connected like this. Okay, same these 2 capacitors, I can connect it like this also. Same these capacitors, I can connect it like this also. Okay, or instead of 2 capacitors, if I have 3 capacitors, I can connect it like this also. 3 capacitors. So these are different ways we can arrange the capacitors connected to a battery. This is the battery of V volt, C1, C2, C1, C2. This is a battery of V volt. This is C1, C2, C3. This is a battery of V volt. Clear? So these are different combinations. Okay, so this combination will be called a series combinations. This combination will be called a parallel combination, and this is a mixing of series and parallel both. These two are first connected in parallel, then in series with these ones. Okay, it is not something like very unusual to us, because we have done combination of resistances in class 10. Okay, so we basically understand what is series and what is parallel. Just a reminder to you, this is called, we'll be calling a series combinations. This is parallel combinations. So in this kind of combinations, what exactly we are going to do today, that we are going to find equivalent capacitance, like the way you have found equivalent resistance in case of resistor circuits in class 10. Okay, on a similar line we are going to do it. Now question is, what exactly you understand by equivalent capacitance? First understand that particular point. Equivalent capacitance. Okay, for example, these two capacitors are connected in series. These two capacitors are connected in series. These two capacitors are connected in parallel. Now these two capacitors are connected in series. These two capacitors, I want to replace it by a single capacitor. I want to replace these two capacitors by single capacitors. Okay, in such a manner that here these two capacitors, for example, a charge Q has flown from here. Okay, right, this way a charge of plus Q will get deposited here, minus Q, plus Q, minus Q, and Q will be coming out. Regarding this distribution, so I'll be talking you again, but let me first describe equivalent capacitance. So here what you have seen, a charge Q is coming in, depositing here, and again charge Q is coming out. Okay, or charge Q is coming out from this side, charge Q is getting deposited. Whatever it is, you see a charge, these two capacitors, because of these two capacitors, a charge Q has moved or flown in the circuit. Now these two capacitors, I want to replace it by single capacitors. Single capacitor. Now this capacitor will be called as equivalent of these two. Will be called as equivalent of these two. If this single capacitor draws the same amount of current, as it was done by these two capacitors. Similarly, instead of this one, suppose these two batteries, these two capacitors, from this battery draws a charge of Q dash, and this side is Q dash. Okay, so there will be Q1 minus Q1, they will become Q2 minus Q2. Here Q dash will become Q1 plus Q2. This one also I'll discuss little later. Okay, so these two capacitors, I want to replace it by single capacitors. Single capacitor. Okay, now this single capacitor will be known as equivalent of these two if this single capacitor draws the same amount of charge as done by these two. Same situations, here the three capacitors, I will be replacing it by a single capacitor. These three capacitors, I want to replace it by single capacitor. Then this single capacitor, for example, a charge of Q double dash is being drawn now from this battery by this group of capacitors. So this group I am replacing by single capacitor. Then this single capacitor will be known as equivalent of this group if it draws the same amount of charge from the same battery as it was done by the whole group. Then it will be known as equivalent of this group. Okay, so that is the definition of equivalent capacitance. Okay, so equivalent capacitance means a group of capacitor when replaced by a single capacitor. If the single capacitor draws the same amount of current, say same amount of charge from the battery, then the single capacitor will be known as equivalent of the group. Clear? Now coming to the series connection. Coming to the series combinations. For example, this will be called as series combinations. Achha, before going to the details of that, let me show you first two. Series combination. This capacitor of capacitance C1, this is of capacitance C2. Now we can say a charge Q will go and deposit on the first capacitor. On the second capacitor, a charge of minus Q will develop. And on the third plate, a charge of plus Q will get developed. So why minus Q and plus Q? Remember, these two plates are not connected to the battery directly. Are they connected? This one is connected to the battery. This one, it is also connected to the battery. These two plates, they are not connected. So they are isolated plates. If they are isolated plates, net charge on these plates will have to be equal to 0. So if one is minus q, the other will have to be plus q. Or you can say a charge q will come and deposit here, minus q and plus q will get developed, minus q will be attracted and plus q will be repelled. So plus q will finally flow and deposit here. So this plus q will induce minus q and plus q, minus q and plus q, minus q will be attracted and plus q will be repelled. This way also you can explain it. Okay, so this is how the charges will appear. So what we have seen in series connection, same charge appears on all capacitors irrespective of their capacitances. They are not having same capacitances, but their charges appearing on them are same. This happens in what? In series connections. Okay, like in series connection resistances, what was that? Same current was passing. Okay, if you think about resistance, connection of resistance, this is you have done already in class 10. Two resistances R and R2 said to be in series if same current passes through both, then they are said to be in series connections. Okay, so total potential drop between this point and this point, between this point, if I call this potential to be V, this potential if I call this potential to be 0, then this potential is V, means between these 2 points the potential drop is what? V. Okay, so regarding this also we'll be discussing, okay, later on. So let me say the potential drop across this capacitor is V1, that is between these 2 points. Let me call this A, B and C, and between these 2 point potential drop is V2. Then what is that? V is equal to V1 plus V2. Okay, now this particular group I want to replace it by single capacitor, and that single capacitor I'll call as the equivalent of these two. So this group I am replacing by single capacitor, I'll call it equivalent, connecting to the same battery, okay. So what we'll see, same charge should flow in the circuit, okay, that is plus q and this is minus q. Now I'll call this this capacitor is the equivalent of these two. Okay, then in this situation what we'll get? V is equal to how much? Q divided by C equivalent. From this particular first capacitor, what is the charge? Q. What is the capacitance? C1. What is the potential drop? V1. Then how much will get V1? V1 is nothing but Q by C1. Similarly, to the second capacitor, what is the charge? Q. What is the capacitance? C2. What is the potential? V2. So how much is V2? V2 is equal to Q by C2. Now, using this particular relation, V is equal to V1 plus V2. How much is V1? How much is V? V is nothing but Q divided by C equivalent. How much is V1? Q by C1. How much is V2? Q by C2. So 1 by C equivalent is nothing but equal to 1 by C1 plus 1 by C2. So this is equivalent capacitance in case of series connections. This is unlike resistors. Okay, so this is similar to the parallel connection of resistors. Okay, this is equivalent capacitance. Okay, we have seen V1 is equal to Q by C1 and V2 is equal to Q by C2. C2. So what is V1? Potential difference between A and B. This is the positive plate, this is the negative plate. So when you're going from A to B, you're going from positive to negative, there is a drop. Again, when you go from B to C, this is the positive plate, this is the negative plate. When you go from positive to negative, there is a potential drop. and when you go from negative to positive, there is a potential up, there is potential rise. Okay, like the way there is a potential drop, there is a potential rise. For example, you are going from this level to this level, what do you call, there is a drop. But if you're going from here to here, there is a potential, there is a rise. Okay, similarly, if there is a particular point, suppose 10 volt, there's another point 5 volt. Okay, so this is going to be positive, this is going to be negative. We'll call this is at higher potential, this is at lower potential. So when you're going from here to here, there is a drop because you're going from higher to lower. And when you come from suppose B to A, you're coming from B to A, then there is a potential rise because you're coming from 5 to 10. So this will be a potential rise. So when you're going from positive plate to the negative plate, there is a drop, and when you're coming from negative to positive, there is a rising potential. Keep that in mind. Okay, so in this potential, in this particular circuit, potential at A and potential at B, the drop is what? V1. So how much is V1? V1 is a potential drop between A and B. Okay, how much is V1? V1 is equal to Q by C1. How much is V2? Q by C2. Therefore, we get V1 by V2 is equal to what? C2 by C1. Or we can write it as Q is equal to C1 V1 is equal to C2 V2. We can write it like this also. So here we have seen like this in series connections. Remember this point very carefully. In series connection, what we have seen, V1 by V2 is C2 by C1. So what we can write it as V1 to V2 is equal to 1 by C1 is to 1 by C2. We can write it like this also. So we have seen potential is inversely proportional to capacitance. That is, capacitance is more, potential drop will become less. Or capacitance is less, then potential drop across that capacitor will become more. Where? In series combinations. So in series combination, let me point out a few important points. 1 by C equivalent is 1 by C1 plus 1 by C2. So therefore C equivalent will become, if you take LCM, then take the reciprocal. First take LCM, then take the reciprocal. How much will get? C1 C2 divided by C1 plus C2. First point you remember here, this C equivalent is smaller than C1, is smaller than C2. So in series combination, equivalent capacitance in series combination is smaller than the smallest in the circuit. First point. Okay, equivalent capacitance in series combination is smaller than the smallest. I'll show it in an example. For example, let me connect two capacitors. One is 6 microfarad, the other is 3 microfarad. I'm showing it with an example of suppose 10 volt battery. Okay, what is the equivalent of these two? So if I have to find the equivalent capacitance here, C equivalent will become how much? 6 into 3 divided by 6 plus 3. 6 plus 3 is how much? 9. How much you have got? 2 microfarad. So out of these two capacitors, which was smaller? 3 microfarad. How much we have got? 2 microfarad. So equivalent capacitance in series combination is smaller than the smallest. This is point number 1. Note it down. Second point. V1 is equal to Q by C1 and V2 is what? Q by C2. What we have got? V1 by V2 is equal to C2 by C1. What I have said from here, that V1 is to V2 is equal to 1 by C1 is to 1 by C2. That means in series combinations, potential drop is more across a smaller capacitor, and potential drop will become lesser against a bigger capacitor. You can say inversely proportional. Let me show you in this example. Now in this circuit, how much we have got? C equivalent. C equivalent is what? 2 microfarad. Okay, that means this particular circuit I can replace it by a single capacitor. How much is the single capacitors? C equivalent. How much is C equivalent? 2 microfarad. So what do you think? How much charge will flow in the circuit? Q is how much? So Q is nothing but C equivalent into V. That is 2 into 10. 2 into 10. 20 microfarad into volt. So how much will become? Microcoulomb. 20 microcoulomb is the charge which is going to flow here. So what is the charge that is going to flow here? Is 20 microcoulomb. So the charge here is 20 microcoulomb minus 20 plus 20 minus 20. The charge across both capacitors are 20 microcoulomb. So this is 20 microcoulomb and 20 microcoulomb. So let me therefore find out how much is V1. Therefore V1 is equal to what? Q by C1. How much is that? 20 divided by, how much is C1? 6. 20 microcoulomb by 6 microfarad. So micro getting cancelled. So you will be left out with 10 by 3. That is 3.33 volt. This is the potential drop across the 6 microfarad. Similarly, how much is the potential drop across the 3 microfarad? V2. V2 is how much? Q by C2. Q is what? 20 microcoulomb. C2 is how much? 3 microfarad. So how much you are getting here? Okay, 6.7 volt. So what I have seen across this one 6.7 and across this one 3.3. Bigger capacitor, smaller drop. Small capacitor, bigger drop. Where? In series combination. Keep that in mind. So if you connect many capacitors in series, C1, C2, C3, C4, Cn, then equivalent capacitance will become 1 by C equivalent is equal to 1 by C1 plus 1 by C2. How you can do that? You can do that very easily. How can you do that? You can do that. V is equal to V1 plus V2 plus V3 plus Vn. Okay, so V can be replaced by Q by C equivalent, Q by C1, Q by C2, Q by C3, Q by Cn. So from there you will be getting 1 by C equivalent is equal to 1 by C1, 1 by C2, 1 by C3, 1 by Cn. So this is the result of series combinations if it comes in a group. Okay, so let me just show you something here in series combinations. Just have a practice. C and C connected in series. Tell me what will be the C equivalent if the two capacitors of equal magnitude. How much will become? 1 by C equivalent is 1 by C plus 1 by C, that is 2 by C. So how much will become? C equivalent C by 2. So that is capacitance of any of the capacitors divided by the number of capacitors. Let us see it again. Let me call total how many capacitors? N capacitors. N capacitors. Then how much will be the equivalent capacitance? 1 by C equivalent is equal to 1 by C plus 1 by C plus 1 by C plus plus 1 by C. How many 1 by C? N numbers, because how many capacitors are there? N numbers of capacitors are there. So 1 by C equivalent is equal to N by C. This implies C equivalent is C by N. So number of capacitors divided amount of the magnitude of capacitance divided by the number. For example, if I connect 5 capacitors in series, each of same magnitude, how many I have connected? 5. Each of magnitude how much? C, 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 C. Then what is the equivalent capacitance? C equivalent to become how much? C divided by number, that is 5. Okay, this you can quickly do it, no problem. Now let me show you parallel combination. This is basically we understand by parallel combinations. That means positive plate of the battery, negative plate of the battery, positive charge will flow, will get divided. A charge Q will suppose flow, will get divided. Suppose Q1 will come there and Q2 will be coming there. If this is plus Q1, this will become minus Q1. If this is plus Q2, this will become minus Q2. Again from this side plus Q1 will come, this side minus Q1 will come. Finally this particular charge will become Q. Okay, Q, how much is flowing here? Suppose Q1. How much will go there? Suppose Q2. Then we can write Q is equal to Q1 plus Q2, this way. Okay, Q1 plus Q1 will level up minus Q1 plus Q1, minus will stay, plus Q1 will flow out, plus Q2, this side minus Q2 and plus Q2 will get induced, minus Q2 will stay, plus Q2 will be taken out. So finally Q1 and Q2 again join, give you Q. Okay, or we can say a negative plate has drawn a charge of Q1 from here and has drawn a charge of Q2 plus here, plus Q2 here. They got combined, become Q, and this Q has been deposited here. Since this is minus Q2, there will be plus Q2. Since this is minus Q1, there will be plus Q1. This here we can say. Now this is to be replaced by a single capacitor, which we will be calling as the equivalent of these two. Okay. Plus minus V C equivalent. Then it should draw the same amount of charge as it was drawn by this group. Then I can write Q is equal to C equivalent into V. Okay. Now what is the potential drop across this capacitor and what is the potential drop across this capacitor? Let us understand this particular point very carefully. See, this particular plate is connected to this point and a negative plate is connected to that point. Here also this positive plate is connected to this point and negative plate is connected to that. That means negative plates are joined and the positive plates are joined. This is another definition of parallel connections. Okay, right? So what will happen here? Potential across this capacitor and potential across this capacitor is going to be the same because they are connected across same points. But this is connected to the positive plate of the battery and this is connected to the negative plate. So what is the potential difference across this battery? V. So what is the potential difference between these 2 points? Is also V, right? So therefore Q, how much we have got? Q is equal to C equivalent into V. C equivalent into V. How much is Q1? Q1, this capacitance is C1, this capacitance is C2. Q1 is nothing but C1, charge is nothing but capacitance into potential drop. So capacitance is C1, potential drop across the capacitor is potential drop between these 2 points, which is nothing but equal to V. So Q1 is equal to C1 into V. Similarly, Q2 is equal to C2 into potential difference, and potential differences between these 2 points is nothing but they are directly having connected to the positive plate and negative plate. So potential drop across this capacitor is nothing but potential drop across the battery. So it becomes C2 into V. So V is same, will cancel out. C equivalent is equal to C1 plus C2. So in parallel combinations, we have seen in parallel combinations, we have seen the equivalent capacitance is equal to sum of the capacitances. Sum of the capacitances, very simple. For example, if I have to connect, this is 6 microfarad and this is 3 microfarad. I have connected them in parallel. Then what is the equivalent capacitance? Equivalent capacitance will become the sum of their capacitances. That is 6 plus 3 is how much? 9 microfarad. So put it into practice again and again, so that, okay, you become very good in that. All right. अब इसमें देखो एक बार. See here something. One thing you see here. What is the charge on this capacitor? Q1. Q1 is how much? C1 into V. Another is Q2. Q2 is how much? C2 into V. So what you get from here? Q1 by Q2 is equal to C1 by C2. That is in parallel combination. The capacitor having bigger capacitance will hold bigger amount of charge. What you have seen from here, Q directly proportional to capacitance. Okay, so more is the capacitance, more charge the capacitor will hold. Let me show you again. Let me take that example of 6 microfarad and 3 microfarad, right? Let me connect it across a 10 volt battery, plus minus. This is 6 microfarad, this is 3 microfarad. The charge here is Q1 and the charge here is Q2. Plus Q1 minus Q1, plus Q2 minus Q2. Okay, then how much is Q1? How much is Q1? Q1 is equal to C1 into V. Potential drop between these 2 points is nothing but how much is that? That is nothing but 10 volt. Okay, C1, that is 6 microfarad. C1 into V. V means 10 volt. 6 10s is 60 micro volt into farad is nothing but coulomb. Have you seen? Similarly, Q2 is equal to C2 into V. Q2 कितना था? How much is Q2? C2 into potential difference. C2, how much is C2? 3 microfarad into potential drop 10 volt. How much is that? 30 micro coulomb. Farad into volt is equal to coulomb. So what you have seen here, capacitance is double of this one, so here charge is double of this one, so it is directly proportional. So what you have seen in parallel combination, in parallel combinations you have seen that equivalent capacitance, C equivalent is how much? C1 plus C2, number 1. So first point, again you remember, in parallel combination, the equivalent capacitance is going to be larger than any of the individual capacitance. For example, here it was 6 microfarad and 3 microfarad, and how much was equivalent capacitance? 9 microfarad. So 9 is greater than 6 also, 9 is greater than 3 also. This is what is going to happen in parallel combination. Okay, equivalent is going to be greater than any of this, number 1. Number 2, what we have seen, Q1 by Q2 is equal to C1 by C2. Q1 by Q2 is equal to C1 by C2. Okay, so in parallel combination, the potential drop across these 2 capacitors is same. Okay, that is going to be equal to V. Potential drop across this one is also V. Potential drop across this one is also V. Okay, so but since the capacitances are not equal, okay, so charges is not going to be same. Charges will become different. The one, if C1 is going to be greater than C2, then Q1 is going to be greater than Q2. We have seen here 6 is greater than 3. This is double. So here charge storage also, this is 6 microcoulomb and this is 30. So this is 60 microcoulomb, this is 30 microcoulomb. So this is greater than this one. So charge stored in the capacitor will be directly proportional directly proportional to their capacitance. In what connection? In parallel connections. Okay. So instead of two capacitors, if I connect many capacitors in parallel, C1, C2, C3, many capacitors in parallel. Okay, so I have to join them in such a way their like plates should be joined together. This is the connection, plus minus. Parallel means on the side all plates will become positive, that is all positive plates are connected to one point. The other side plates would be negative, they are all negative plates are joined to the other point. C1, C2, C3, suppose Cn, n capacitances. Okay. Then what will be the equivalent capacitance? Equivalent capacitance will be sum of the individual capacitances, that is C1 plus C2 plus C3 plus plus Cn. Similarly, charge on each capacitor will become different. Q1, Q2, Q3, Qn, and total charge in the circuit is equal to Q. Suppose total charge flown from the battery is Q. Then total charge Q will become Q1 plus Q2 plus Q3 plus plus Qn. Okay, so the ratio of the, what is the amount of charge? Potential drop across all are going to be same, that is V. Okay, all the capacitors are connected between these two points. This is connected between the point A and point B. Second is also connected between A and B. Third is also the NF also. So in parallel combination, potential drop across all capacitances are same. Okay, and they have got different capacitances, so the charge accumulated on them will become different, and total charge is sum of the individual charges. Okay, Q1 is entering, Q1 will come out, Q2 is entering, Q3 like this. Okay, total charge here is again Q. So this is your parallel combination. Okay, now let me discuss few more points on it. Now series question. Now series questions on the screen. First one. Okay, what do you have to find? Two capacitors C1 and C2 connected across a battery of V volt. We have to find V1 and V2, that is potential drop across capacitors C1 and C2 in terms of C1, C2 and V. Also find the total charge on each capacitor. Okay, so if we take one capacitor C1, the other is C2. This is C1, that is C2. This potential is V1, that potential is V2. What is the potential of the battery? Potential of the battery is V volt. So you have to get how much is V1 in terms of V, how much is V2 in terms of V. Okay, so how we can solve it for finding V1? We can, let's say one of the method is, so what we'll do, first we'll find the equivalent of C1 and C2. This is one method I'm showing you. How much will be the equivalent of C1 and C2? We know C equivalent will become C1 into C2 divided by C1 plus C2. Why? They are connected in series. They are connected in series. This is C equivalent. Okay, then what is the charge? Okay, that will be flowing in the circuit Q. Q will become how much? Q will become C equivalent into V. What is C equivalent? C1 into C2 divided by C1 plus C2 into V. Okay, that is in this particular circuit, how much charge is flowing? Q charge is flowing, which will deposit here, plus Q minus Q, plus Q minus Q. Same charge will appear on both capacitors in case of series connections. So look at the first capacitor. Capacitance C1, charge Q, potential difference V1. So you got V1. How much is V1? V1 is equal to Q divided by C1, And what is Q? Q is that C1 C2 divided by C1 plus C2 into V by C1. So one of the C1 is getting cancels. So V1 is nothing but C2 divided by C1 plus C2 into V. Similarly, V2, now you can tell directly V2. V2 will become as V1 C2. So V2 will become as C1 divided by C1 plus C2. Okay, or you can do it like this. V2 is equal to Q divided by C2. And when you do Q, you replace Q divided by C2, how much you'll get? C1 divided by C1 plus C2 into V. This is the capacitance. These are a potential drop across both capacitors in series connections. Okay, and that is the total charge drawn from the battery. Same charge will appear on both capacitors. So charge on each capacitor is equal to C1 C2 divided by C1 plus C2 into V. Go to the second questions. What is the second questions? And the second question, what is the second questions? Again, two capacitors. One is capacitance C, the other is having capacitance N times of it. Potential difference is V volt. What they're asking the questions? Find VA. This point is A, this point is B. Okay, point A, point B, point C. We have to find VA minus VV. So what is VA minus VV? Is nothing but V1. What is VB minus VC? Is nothing but V2. V minus potential of C means potential difference between B and C. That is the potential difference across the second capacitor, V2. Okay. So we can use the previous formula, or we can do it in detail. Let us do it in detail. So what we'll do first? We'll find equivalent capacitance. We'll find what? Equivalent capacitance. How much is the equivalent capacitance? C1 into C2 divided by C1 plus C2. This is what we're going to get. So how much is that? N divided by 1 plus N into C. That is the equivalent capacitance. So what will be the charge Q then? So Q will become equal to C equivalent into V. C equivalent. C equivalent is what? N divided by 1 plus N into CV. This is Q. So therefore VA minus VV. VA minus VV is nothing but V1. What is V1? V1 is nothing but Q divided by C. Q divided by C. So how much will get Q divided by C? This is Q. Okay, this is Q. Bring C here. Q by C. Q by C will become how much? N divided by 1 plus N into V. Similarly, VV minus VC. VV minus VC is what? V2. That is potential drop across this capacitor. How much is that? Charge. Same charge Q will appear here. Charge divided by capacitance. That is Q divided by NC. N and C is there. Bring it to the left hand side. Q divided by NC will become how much? V divided by 1 plus N. Okay. These are the second questions. Try to understand. It's just having this, we are just having this practice. Okay. So that no confusion remains here. Okay, because once this particular part is clear, the rest everything you will understand. Third questions. What is the third questions? The capacitance is C1 and C2 is just a repetition. C1 and C2 connected across a battery of V volt. What do you have to find? We have to find net charge drawn from battery and charge on each capacitor. Net charge drawn from the battery and charge on each capacitor. This is C1. That is Q. So what we'll do? Again, we'll find equivalent capacitance. I'm showing you one method only, right? There are many ways you can do that. Okay. Okay, let me show you here two methods. Charge on each capacitor. Okay, so let us find out C equivalent. How much it becomes C equivalent? C equivalent is equal to C1 plus C2. Now see how we can do it. So what will be the total charge drawn from the battery? Q is equal to C equivalent into V. C equivalent into V. What is C equivalent? C1 plus C2 into V. This is the total charge drawn from the battery. So this is the Q going. Suppose the charge here is Q1 and the charge here is Q2. Then Q1 will become how much? C1 into potential difference, which is V volt. Okay, Q1 will become C1 into potential difference, which is V volt. Similarly, Q2 will become what? Capacitance into potential difference between these 2 points. And between these 2 points, what is the potential? Between these 2 points, potential is nothing but V. Q2 is equal to C2V. Okay, or you can find one thing. You can find Q1, Q2, then add both. You will be getting the value of Q. That also you can do it. First, you can find out Q1. Q1 is nothing but C1 into V. Q2 is nothing but C2 into V. Potential difference between these 2 points is V. Then Q is nothing but Q1 plus Q2 you will get in that way also. So if I call one of the capacitance to be C and the other to be NC, N times C, then Q1 will become CV, Q2 will become NCV, total charge will become Q is equal to Q1 plus Q2, Q1 is equal to CV, Q2 is equal to NCV, so it will become 1 plus N into CV, 1 plus N into CV. This is the next question. Achha, let me try questions out here on this point. Suppose let me use two capacitors. And the magnitude of these two capacitors, one is suppose your 3 microfarad and the other is your suppose your 2 microfarad. And a charge of for example 10 microcoulomb is coming. What is the total charge coming? 10 microcoulomb. Okay, 10 microcoulomb. Find charge on each capacitor. Find charge on each capacitor. Okay, try it. Do it. कैसे करोगे? How to do it? This is let me call Q1. This will let me call Q2. Okay. Bigger capacitor, bigger charge. Smaller capacitor, smaller charge. Okay. So here one thing we know, we have already seen Q1 by Q2 will become C1 by C2. How much is C1? 3. How much is C2? 2. Okay. So the total charge will get divided into 2 parts. Here 3 parts, here 2 parts. So we got our answers directly. Total how many parts? 5 parts. Out of 5 parts, 3 parts will go there and 2 parts will come here. That means 10 microcoulomb we have to divide into how many parts total? 5 parts. Out of 5 part, I have to take 3 part there. Out of 5 part, 3 part means if I divide into 5 parts, each part will become 2 microcoulomb. Okay, so each part will become 2 microcoulomb, and here 3 parts means 3 to the 6 microcoulomb will be here. From here, Q1 is equal to 3 by 2 Q2. Again, doing it in detail, again, Q1 plus Q2 is equal to 10 microcoulomb total charge. Okay, Q1, how much is Q1? 3 by 2 Q2 plus Q2, 10 microcoulomb. Let me take LCM here. Okay, if I take LCM, or if I just add it, 3 by 2 plus 1, how much will become? 5 by 2 Q2 is equal to 10 microcoulomb. So Q2 will become how much? 2 is 4 microcoulomb. Since Q2 is equal to 4 microcoulomb, therefore Q1 will become 3 by 2 Q2. So 3 by 2 is 4 microcoulomb. This will become 6 microcoulomb. This is how we can calculate it in detail. Otherwise, the ratio of the capacitance, parallel combination, ratio of the capacitance is 3:2. So the ratio of the charges will become 3:2. Clear? Ratio of the capacitance is 3:2. So the ratio of the charges will become 3:2. So here 3 part, here 2 part. Total 5 part. 10 is to be divided into the 5 part. Each part will become 2 microcoulomb. So put here 3 parts, that is 6 microcoulomb. Put here 2 parts, that is 4 microcoulomb. This is how we can do it directly also. Okay. In a similar situations, so in parallel combination, we do not talk about potential difference because potential difference across both are going to be same in parallel. And in series combination, we hardly talk, we are not in this kind of situation. We do not talk about what are the charges on each capacitor, because in parallel, in series combination, charge on each capacitor is going to be the same. Okay, let's see. Let us try these questions. Suppose this is 3 microfarad. Again, this is 2 microfarad. Okay, between point A and point B, a total potential difference of VA minus VV. How much is applied? Suppose 10 volt is applied. What is the potential difference between A and B applied? 10 volt. Find, okay, potential drop across each capacitor. Chalo, do it quickly. Find potential drop across each capacitor. What is the potential drop across 3 microfarad? V1. What is the potential drop across 2 microfarad? V2. Between A and B, what is the battery connected? 10 volt battery is connected. I'm not showing the battery, but you need to understand as if a battery has been connected whose potential difference is 10 volt. Okay, do it. V1 we can. So we know in series combination of capacitances, the potential drop is inversely proportional to the capacitances, C2 by C1. So in this situation, how much it will become? It will become C2, that is 2, 3. So total potential drop between A and B is 10 volt across the first capacitor. Okay, this is C2. Across the first capacitor, how many parts? 2 parts. Across the second capacitor, how many parts? 3 parts. So 2 part will be dropping here and 3 part drop will be there. That means 2 part means 10 is to be divided into 5 parts. Out of 5 part, 2 part means 4 volt and 3 part means 6 volt. 6 volt. Let's see here, I'm doing it. So V1 is equal to 2 by 3 V2. Now V1 plus V2 is equal to V. How much is that? 10 volt. How much is V1? 2 by 3 V2 plus V2 is equal to 10 volt. 2 by 3 plus 1, 5 by 3 V2 is equal to 10 volt. So from here V2 is how much? 6 volt. Okay, therefore V1 is how much? 2 by 3 V2, 2 by 3 6 volt, that is how much? 4 volt. Okay, understood? Now let me tell you one more point. Here let me introduce one more point, C. And now let me ask you, what is the potential at C? Okay, so for that let me take a different question. For that, let us take this problem. C1, at this point potential is V1, or C2, at this point potential is V2. For example, V1 is supposed 20 volt and V2 is supposed 12 volt. 4 microfarad and C2 is equal to 2 microfarad. Okay, so what will be the potential at the middle point? How much will be the potential at the V? Okay, C1 and C2 are given. How to find out the potential at C? Okay, so one thing we know, since they are connected in series in both capacitors, charges is going to be the same. Charges is going to be the same. So how much is C1, or what is the charge Q here? If charge here is Q, then charge here is also going to be Q. How much is Q? C1 into potential difference. C1 into potential difference. How much is potential difference? V1 minus V. Similarly, here also charge is how much? Capacitance into potential difference. What is the capacitance? C2. What is the potential difference? V minus V2. V minus V2. So from this relation, C1 is known to us, V1 is known to us, C2 is known to us, V2 is known to us. What is not known to us? What we do not know? V. So one equation, one unknown, we can get the answer easily. See how to get it? C1 V1 minus C1 V is equal to C2 V minus C2 V2. So if I bring C2 V2 on this side and take C1 V to the other side, then I'll get C1 V1 plus C2 V2 is equal to C2 V plus C1 V. So from here I can take V common. From here I can take V common. C1 plus C2 into V. Acha, write it here. So C1 plus C2 into V. So therefore, what is V? V is nothing but C1 V1 plus C2 V2 divided by C1 plus C2. This is how we need to work. Of course, we have the options here. C1 is how much? 4. V1 is how much? 20. Okay. Plus C2 is how much? 2. And V2 is how much? 12 divided by C1 plus C2. C1 plus C2 is nothing but 6. So 80 plus 24. 80 plus 20. 80 plus 24, that is 104 divided by 6 volt. How much that will become? Should be less than 20. Should be less than 20 but more than 12. So this will become 144, 6, 7 42, 6, approximately 17.3. Or we can solve this problem directly also. To make you understand, let me take some easy values. Here suppose potential is your 20 volt, and here suppose potential is your 10 volt, and let me take here suppose your 11 volt. Okay, so this is 2 microfarad and this is 1 microfarad. We have to find a potential in between. Okay, so for that, what we'll find out? What is the potential difference? We'll find out V1. We'll find out V1. How much is V1? Let me call this point as A, this point is B, this point is C. Okay, how much is V1? How much is V2? To find V, we know the potential at A. To find a potential at C, we have to know what is the potential drop across this capacitor. So for it, we can use a shortcut method. What is a shortcut method? Between these 2 points, what is the drop? 20 minus 11. Okay, 20 minus 11. How much is that? 9 volt. So potential drop between these 2 points is what? 9 volt. And the capacitances are in the ratio 2:1. 2:1. So potential will be in the ratio 1:2. That is 1 part here and 2 part here. Why? Because V1 by V2 is equal to C2 by C1. In case of our connection, series connection. In case of our connection, series connections. See carefully. Total potential drop is how much? 9 volt. Capacitances are in the ratio 2:1. Capacitances are in the ratio 2:1. So potential drop will be in the ratio reciprocal. Okay, 1:2. Okay, 1:2. So 1 part is here and 2 part is there. Total how much? 9. 9 is to be divided into 3 parts. So if I divide 9 into 3 parts, each part will become 3, 3, 3. So 1 part means 3 volt. And 2 part means 6 volt. Across this one, drop is 6 volt. Across this one, drop is 3 volt. Then 3 divided by 6. 3 divided by 6, 1:2. Okay. So what we have seen, V1, we have got it to be 3 volt. How much is V1? V1 is nothing but VA minus VC is 3 volt. How much is VA? 20. Okay. Minus 3 is equal to VC. How much will be getting? 17 volt. That is the potential at C.